has been IBM. Although Java was clearly invented by Sun and is now owned by Oracle, a lot of the contributions to the Java community process and a lot of the development work has been done by IBM. I'm sure Chris will allude to that.
Yeah, there'll be some content on that.
But what is he going to do tonight? And I should say that Chris is a very good person for this because of his position as the man for Java service problems in IBM worldwide, with responsibility over a number of different labs. The person who actually troubleshoots and directs the solution to the most difficult problems, as his other counterparts for other pieces of IBM software do. So I'm sure he's very much been at the sharp edge in some of these issues. Yeah. So I think somebody who Chris speaks with great authority on the subject, and he's going to tell us about Java, past, present, future. But we're very interested to know where Java is going to and what we can expect to see in the future Java 8 release. So, without further ado, over to you, Chris.
Thanks, Jeff. So Jeff says what I'm going to cover over the next hour is a little bit about where Java came from, and I'll explain how IBM is related to Java. But I'm mostly just going to focus on what's in Java 7, which is the latest version that you can get today, what's in Java 8 that's due to be released in October this year, and then some of the other stuff that's happening which may be in Java 9, some of it might actually happen in the lifetime of Java 8, we don't know yet because it's future work that's going on. But as Jeff says, I work for IBM, which means we have to have one of these. And noticeably, since Oracle bought Sun, whenever the main Java engineering team from Sun, now Oracle, do presentations, they have to have one of these as well. So it's just a bunch of unreadable block capitals that says that anything I say from this point forward could be a lie. But me, so I've been working as part of the IBM Java Technology Center for 13 years. So I've been working on developing JVMs and JDKs. So I've done Java virtual machine development, I've done just-in-time compiler development, I've worked on different bits of the class libraries doing AWT and swing and that sort of stuff. But as Jeff said, I spent a lot of my time working with people doing enterprise deployments of Java to make sure that they work and that they don't hit bugs and to troubleshoot when that happens. Recently I've been doing Java in the cloud, so how Java integrates well into remote server environments on virtualized hardware and software, doing monitoring and diagnostics and working with customers on highly resilient systems. But yeah, most people, like, if you ask anybody to think about Java, they think Sun, Oracle, right? IBM is just someone that uses Java, right? Well, we actually got involved in Java before Java first existed. So we have something called the IBM Java Technology Center. It's based in multiple locations, so it's a globally distributed team, but we have a group called the IBM Java Technology Center. And what we do is we take reference Java technologies. Now, one of these is OpenJDK and Java as produced by Sun and now Oracle. Other locations for this are things like Apache. So Apache has the Xerox project that does XML and XSLT transforms. There was the Harmony project that did some class libraries. So there's lots of open source groups out there which are doing things with Java. So we look at a lot of those. We're actually the major contributors to a lot of them. So Xerox was a project that largely came out of IBM. Eclipse is a project that was founded by IBM and so on. So it's not that IBM takes open source stuff, it's a community collaboration between the two. So we take these technologies and bring them into the IBM Technology Center. In the case of OpenJDK, IBM and Oracle are considered to be the two major partners in OpenJDK. So we do a lot of the OpenJDK development as well. So we take that technology in. We then do what IBM considers to be quality engineering. So we look at improving reliability, serviceability, that's monitoring and diagnostics, doing huge amounts of testing, and making sure that Java works on IBM's platforms, which are AIX, Linux on mainframes, Linux on Power Series boxes, and we also do a version on Windows and Linux Intel as well. We take in a bunch of requirements from groups around IBM, IBM business partners, IBM software vendors, and our end clients and customers to work out what things need to be put into Java. Those all get handed back to OpenJDK or to the open source groups when we do that. And what drops out the other end is what we call IBM Java. So we do have our own versions of Java. And what's inside IBM Java, kind of the key bit's the bottom right-hand corner. So when you get a JDK, a Java runtime from IBM, what you get is a Java virtual machine that's created by IBM. We have our own Java virtual machine. Oracle has their own called Hotspot, so basically we have our equivalent. Then there's the core class libraries. So these are things like Java util, Swing, AWT, all of that sort of stuff. Now that box is mostly red with a tinge of blue. So when you get it from IBM, it's mostly exactly the same code you would have on the release from Oracle. But there's little bits in there that we've done in order to make it work with the IBM Java virtual machine, which runs on the IBM platforms. We then add in 3 packages, which are IBM technology. We do our own version of XML, crypto. So we do security packages that have US federal government compliance, and that integrate with different hardware and has acceleration support and so on, because our clients ask for it. And we have our own version of the core drawer. That's kind of a strange one. So if you use something called RMI IOP in Java, IBM actually created that. It's something that we came up with and we made available to Sun at the time. Sun looked at it and said, oh, we'll do our own. So we were kind of there first. Oracle or Sun came second. They chose to keep their own version. But for AWT, Swing, Java 2D, all the other stuff, we use exactly the same code as Oracle does. So if you take your Java application and you want to run it on the IBM JVM or you want to run it on the Oracle JVM, it should just run because we use the same class libraries. The APIs, the interface that you use is identical. We aim for what's called bug-for-bug compatibility. So the behavior is identical. You go to the API spec and it's a bit grey, it's a bit vague about how it should work. Well, we try to make sure it does exactly what it does on the others. So write once, debug anywhere applies. So that's what we produce. And as Jeff said, we've kind of got a worldwide development team. So we've got a team in Hursley, near Winchester, which is where I work. We do integration, delivery, customer support. We do monitoring and diagnostics there. We've also got a team in Ottawa in Canada. So Ottawa do the Java virtual machine for Java ME, so for Micro Edition, for SE, so desktops and standard edition, and EE, the enterprise edition. They use the same JVM in all cases. We've got a team in Toronto that does our JIT compiler, which takes your Java code and converts it into machine code. Now, the reason why that's done in Toronto is on the same site, we have the team that does our compilers for C, C++, COBOL, Fortran, etc. So it's a lab of people who know how to do compilers. So we use the same team for Java compilers as for C, C++, COBOL, etc. We've got a team in India, in Bangalore. They do testing, customer support for the right-hand side of the map, so Asia, they're in the time zone for. They do field development as well. We've got a team in Shanghai. They do globalization, they do specialized testing, and they're now doing work on Java in the cloud. And you'll see later on what we're doing in the cloud. And then we've got 3 teams in the US, Austin, Rochester, and Poughkeepsie. They do integration with hardware platforms. So Poughkeepsie is the team that creates the mainframe. So we have a team there that does integration of our Java with the mainframe to make sure it works properly. Likewise, Austin creates our P-series boxes. So we have a team that does P-series integration, and Rochester does I-series. And then we've got a team in Phoenix that does the class libraries for micro edition. So we've got, what's that, nine different groups around the world, usually located where we've got a centre of excellence for something. So Austin, the centre of excellence is Power, so P-Series, so we have a team there that does the integration with Power and P-Series. In Toronto, it's compilation, so that's where our compiler guys are based. So whilst I work for IBM and Oracle is the owners of Java, we do a lot with Java, and we have been for something like 16 years, I think it is. So that kind of brings us to the timeline for Java. So the story of Java kind of started in 1991. So what happened in 1991 was some were interested in investing in finding whether there was anything they could do in consumer electronics. So they created a team called Project Green. And the aim of Project Green was to work out whether they could sell something that works for consumer electronics. And the problem with consumer electronics is there's a vast array of different devices, different hardware, that you've got to deal with. So this is where the concept in Java of write once, run anywhere came from. One programming language works in the same way on all platforms, but it covers a huge number of devices. So that's what they were looking at. And under Project Green, James Gosling started on to work on a programming language called Oak. So that's where they were in 91. In 1992, they did a demo of a PDA called Star 7. That included the Oak programming language. And it pretty much bombed. No one was interested in that PDA. In 1993, they span off Project Green into a subsidiary of Sun called First Person. And what First Person were looking at was creating interactive TV boxes, so set-top boxes to plug into your TV. They were talking to AT&T and these kind of telecoms companies. As a guide of where the industry was at this point, this was the point at which Tim Berners-Lee started talking about W3 at CERN. So this is when the World Wide Web became available at CERN for the first time. Meanwhile, Sun is looking at doing interactive devices for set-top boxes. So in 1994, they took the stuff that they were doing for set-top boxes, which still no one was particularly interested in, and they used the Oak programming language out of it to create something called WebRunner. Now, WebRunner was effectively a browser with Oak support, and this is back in the day where browsers only did static content. And what they did was they had a demo of a molecule that could be moved in the browser as the mouse moved. And this was considered to be radical at the time. And that was the time that Netscape was first released. So back in '94, Netscape first releases Navigator, and Sun has this thing called WebRunner, which allows you to move something inside a browser. Okay, in 1995, Oak became Java. Now, the reason why Oak became Java was a trademark dispute. So there was something called Oak Technologies, and they were worried about using the name Oak, which apparently was named because James Gosling had an oak tree outside his office window. But they moved it over to be called Java. They made a beta of Java available on a very small website, and they got a huge amount of traction within the first couple of months. And they did a demo of their WebRunner browser at TED. So at this point, Netscape announced that they would adopt Java. So what happened in 1996 was Java 1.0 gets released. So at this point, what was to become Java had already been 5 years in the making through the programming language called Oak. In the first version, there wasn't too much there. There was a programming language. There was a version of AWT, but they changed the event model pretty quickly in 1.1, and they had the WebRunner browser. As happens early in the lifetime of a programming language, you quickly have to do stuff to make it easy for programmers to actually do something real. So 1.1 came out in '97, where they started allowing you to have inner classes for the first time. There was Java being support, there was JDBC, remote method invocation, and reflection, so you could do introspection at that point in time. In 1997, they were already saying that they were the #2 programming language for professional developers, and they had 400,000 people using Java at the point that Java 1.1 existed. Java 1.2 came out in '98, and they rebranded Java to call it Java 2. So from there on in, it was always J2 SE. So that came out. There was an update of the UI from AWT to Swing. The first browser plugin, so you could start plugging it into multiple browsers. The Java collections were introduced for the first time, so you have, hash table was introduced as an API in a class that you can use. And then in '99, this is the first time that they started talking about, rather than just having Java, you'll have Java Micro Edition for handheld devices, Java Standard Edition for the desktop, and Java Enterprise Edition for the server. Okay, so that was the first 10 years. But then from 2000 onwards, in 2000 they released what's now J2SE 1.3. They have remote method invocation over the wire with Corba, Java naming directory, Java platform debugger, proxy classes. So they're starting to bring in more function and more support packages so that it's got the rich ability to build applications that do real stuff at this point. They announced Java Web Start, and most importantly, this is where I joined IBM and started making a difference to Java, or not, as the case may be. So Java was officially 4 years old when I joined, but had actually been worked on for about 9 years. When I started, I was working on the 1.18 JDK and the 1.12 JDK and the release for 1.3. In 2001, IBM created the Eclipse project to give you an IDE in order to do development. One of the reasons behind that was you could look at the ability to actually write Java code, and if you compare it to things like C and C++, there was a lot of support from Borland, and there was MS Dev, so there was rich IDEs for doing development for other languages, but not so much for Java. So IBM created the Eclipse project, and when that first came out, I used to do all of my development for the JVM and for the Java class libraries using VI like everybody else. So it was kind of a big change, and I admit I was sat there going, I'm not sure about this UI stuff, it doesn't, don't trust it. But now everyone, I think, uses UIs, so it's very much carried Java forward at that point. 1.4 came out in 2002, giving you assertions for the first time. So now that they've got to 1.4, they're starting to look at actually how the language needs to evolve rather than just supplying more support packages. So you've got assertions and you've got regular expressions, both of which were in other languages for some time. They brought in the logging API, new I/O, which is NIO, which is the ability to do, at that point, non-blocking I/O. XML XSLT was brought in, as was WebStart. And at this point, they're claiming that they've got Java on 550 million desktops. Part of that was when you got Java and you got, when you got a Windows desktop, Java was already on it. So as Windows was prevalent, it was going out to every user. Java 5 came out in 2004. And at this point, they're starting to really concentrate on the language again. So you get auto-boxing, enumeration, generics, metadata, so annotations. So they're all language changes rather than putting in additional support packages. Then in 2004, we've got Java downloads hitting 7 million, 4 million developers. Because of ME, it's on 1.5 billion devices, and there's 550 user groups worldwide. So Java's become pretty massive as of the middle of the early 2000s. The numbers just keep increasing each year. Then Java 6 comes out in 2006. Now at this point, you'll notice there's basically a release of Java every 2 years. So 1.3 in 2000, 1.4 in 2002, 1.5 in 2004, 1.6 in 2006. And what's in there is performance, some changes to the UI, Java console, some changes to the collection framework. Not a lot's happening. So it's like they're starting to run out of ideas. And then in 2006, they released Java under the GPL. It became open source. So that was the first point that Java became the open source platform that it is today. That led to another increase in developers and its usage. But at the same point in time, this was where Sun as a company was starting to struggle. So the fact that we had our last release in, what was it, 2008, means that we should be expecting a new release to happen around 2009, 2010. But that didn't happen because Sun started to try and sell itself. And it was announced late in 2009 that Oracle was looking to buy Sun. And in 2010 it did buy Sun. So at this point, development and release of Java had stopped because of the turmoil around ownership of Java and ownership of the company. So then what happened in 2011 was Oracle announced a roadmap for Java that said, look, most of what we wanted to put in Java 7 isn't ready. So we can either wait until 2012, 2013 for the next release of Java, which is going to be like 7 years since Java 6, or we can get something out in Java 7 2011, and then defer the rest to Java 8 in 2013. So that's the approach that they took. So what went into Java 7 was what they called small language changes. So a bunch of ease-of-use programming changes. New IO2, so they had new IO, they just extended it. Invoke dynamic, which is actually quite important, it's probably the most important thing that happened in Java 7. And some more concurrency work. So what they deferred to Java 8 was Lambda expressions. So that was supposed to be the big thing in Java 7, and it didn't happen. And the other thing that they deferred to Java 8 was modularity. So anyone that's ever used Eclipse plugins in OSGI, the idea of having your application as a bunch of modules which can do dynamic lookup at runtime to get the latest version of it, that is what they were supposed to put into Java 7. They deferred it to Java 8, and if you'll notice the list of Java 8, there's no sign of modularity there. What they have done in Java 8 is compact profiles. So as of Java 8, you'll be able to get multiple different versions of Java SE, which have got stripped out class libraries to reduce the footprint of the bottom. So they've stopped short of doing modularity that they expected to. And that's now kind of being deferred to Java 9. So we're expecting a Java 9 in 2015 that may have modularity in it. We also expect it will probably have work around client virtualization, possibly something called struts 2.0 or packed objects, which is a way of writing data in such a way that other languages can access your data directly without us having to do serialization to transfer it from Java out of the process so that something else can use it. So that's been our timeline over the last 25 years or so, from 91, where Oak started, to 96, where Java was actually released, to 2013, where we're expecting Java 8 to be released around about September this year. So Oracle tries to release Java in time for Java 1. Java 1 should be, I think it's September 26th in San Francisco. So that is their target date to have it out by then. So if we now actually look at what's in Java 7 today, what was that stuff that they actually put in there? As I said, it's not actually much, but there's been a trend to go back and look at the programming language. There's been a lot of competition from other languages these days. There's lots of scripting languages, and there's lots of new language which is designed to make it easier for the developer to write code, rather than be statically typed and being a safe language to use. So it's now all about speed of development. So they're trying to build some of the speed of development into Java. So for Java SE7, basically what happens under the Java community process is there's a whole bunch of JSRs, Java specification requests. And there's an umbrella JSR which, for each release, which is a list of the other JSRs which are going into it. For Java 7, that was 337. And they basically included three main JSRs. The first one is 334, which is called Small Enhancements to the Java Programming Language. The second one was more new I/O APIs called NIO2, and the third is dynamically typed languages. So trying to get other languages other than Java running on top of the JVM. And they did a number of other small changes around security and look and feel and UI work. But in terms of what happened in Project Coin, so when they did small language changes, they termed the project Project Coin because coin is a bunch of small change. So it's a play on words that they came up with. The gist of it is, the first main change that they made was that you can now do a switch statement on a string, something that you've not been able to do in Java today. So you can switch on an int, but you couldn't switch on a string because the string is not a primitive, it's an object. So you used to have to do very painful things if you wanted to switch on the content of the string. You basically had to do a lot of string compares. It still does that under the covers, but as a programmer, you can just write switch string case 1, case 2, case 3, and so on. In fact, all of the changes under Project Coin are just compiler tricks. It's not changed the base runtime at all. It's changed how the compiler interprets your code and allows you to do things in code that you couldn't do before. So the first one is switches on strings. The second one is, so in Java 5 they introduced generics. So you could take something like a map, and you could say inside my map I have two types of data. One is a string, and the other one is another type. I could declare it as map string string. Now it used to be really frustrating that when you declare your map as being a string and a string, you then have to say, well, new hash map string string, or string my type in this case. So you basically had to do the same thing twice. And they kind of worked out that we can infer the right-hand side from the left-hand side. So now you don't have to do it, and the compiler fills it in for you effectively. The third is the way you can declare literals. So you can now define binary literals. You used to be able to do hex, not octet, no.
Octal.
Octal, that's the one. Yes, you used to be able to declare octal. You can now declare binary, and if you want to, you can now put underscores in numbers. So if you wanted to put an underscore in a number to make it visually easier to see what the number is, so in the same way that we put a comma every 3 zeros, and on the consonant they put a full stop every 3 zeros, you can put an underscore in so that you can make it easier for you to read the literal. And they've added some simplified var support as well. Another thing that they've done is multi-catch. So if you have a try block that throws multiple different exceptions, previously you had to handle each of those exceptions separately. So if you could have a null pointer exception and an IO exception, you had to do 2 catch blocks, one for each, or use the top level exception and accept that they're both subclasses of that. And that doesn't work with errors. So if you could get both an error and an exception, you had absolutely no choice but to write 2 catch blocks. What you can now do is do a multi-catch. So you declare the types that you want to catch with a vertical separator between them, and it will run the same code for all exceptions of those types. So again, it just saves you having to do more work as a programmer when you're writing your code. Another one is automatic resource management. So you can now put things like the opening and closing of file streams. Right? You have to close these streams down manually. Now, usually the best practice approach for that is you do your try block, you do a catch, you do a finally, you close it in the finally. You no longer have to do that finally because it will do it for you. So you write a try block that creates some streams. If it fails to create the stream and you would normally have to close it down, it effectively puts the finally block in for you. So again, it's a compiler trick to make it easier for the program. New IO2. So what was introduced in Java 6 was new IO, and that gave non-blocking IO. What's been introduced in new IO2 is asynchronous IO. So you have a futures object or a completion handler And what you can do is basically farm off work packets which will return to you once your I/O is completed. So you can allow I/O to happen on other threads without you having to worry about it, and it's a simplification again. They've also introduced the improved file system API. So if you've ever tried to write code that integrates and interacts with the file system, it's been very, very painful. It doesn't let you do much because most of the operating systems deal with their file systems different ways. So they've reworked the file system API so that you can actually do things with the file system without having to reach out to native code or starting to do runtime execs. So they've added a lot of flexibility in there. One of the things in particular is you can actually set a watch point on a file name and be notified when that file has changed. Previously, you had no choice but to write a poll that continually goes to the file. And there's been work on the concurrency and collections. So if you ever do parallel work, fork join was added in Java 7. So the ability to do multi-threaded work over a data set. That was added, which is very useful for anybody that is doing parallel processing or trying to break down huge sets of work. So it's being exploited by things like Hadoop. Transfer queues is another one. So in Java 6, you got the blocking queue added. And what the transfer queue does is if you put an object onto a blocking queue, the thread that puts it on there now blocks and waits for someone else to take it off the queue before it returns. And they've added more synchronization primitives via the phaser. So all minor things, all for fairly specialized groups. Really the main thing that came into Java 7, which people will use a lot, is the project calling language features. And these are all about trying to compete with other languages where it's already easier. So that brings us to Java 8. So what's going to be happening next? So I will state at this point in time that the JSR 337, which is the umbrella JSR that says what's going to go into Java 8, is not closed. So we do not 100% know what's going into Java 8. We can only tell you where the development line is at the moment and what's likely to be there. So the main thing is Lambda expressions. So being able to put anonymous functions or methods as parameters. An extension to that is something called virtual extension methods. And we'll go through both of those. And then on top of that, there's a whole number of JSRs and what they call JEPs, so Java Enhancement Proposals. And those are really features which are going in which are too small to get a JSR in its own right. So a number of those are being brought in as well. But really, the main two are Lambda expressions and the virtual extension methods. And I'll go through the compact Java SE profiles as well. So Lambda expressions. So in Java at the moment, there's something called anonymous classes. So you can create an anonymous inner class. You can basically create a class on the fly. Now, a good example of where that happens is things like Runnable, or where you're going to use the security provider, where you're adding an event listener. So in this case, we've got an event listener that we're about to add. And the way you would do it is you would say, well, create me a new listener object, and I'm going to override its event callback method, and this is what my event callback method is going to be. So I can create an anonymous inner class as I'm going. So that solves the problem for me, but it's kind of bulky, it's slow to do, and it's a little annoying to have to do it. And you've got some problems with leakage, and there's problems with scoping of variables. So when you are writing code inside here, it's hard to know whether this pointer applies to your inner class or the enclosing class, and it does confuse a number of developers. So what's introduced with Lambda expressions in Java 8 is the ability to create what's effectively anonymous methods. So you can create a method on the fly that you can then pass as a parameter to a function. So if I give you an example, if you had a data set and you wanted to be able to query that data set, you've got two choices of what you could do. Right? You could write a whole series of APIs that says, go into my data set and tell me about, I don't know, marbles which are orange, or tell me about marbles which are bigger than golf balls, or tell me about marbles which are the size of ball bearings. Right? You'd have to have several APIs to be able to have methods that query that data set. What would be much simpler is if you had one API that says query my data set, and I just pass in as a parameter a method that knows how to get the results that I want. So I would pass in a method that says, if marble is blue and greater than the size of a golf ball, return this marble. And that's a one-line method. Now, what lambdas allow you to do is to create anonymous methods and then pass them around as parameters to functions. So basically, what you have here are three lambda expressions. The first one says, create me a method that just returns integer.size. The second one says, create me a method that takes two parameters, x and y, and what it does inside that method is add the two together. So that anonymous method would return x plus y. And the third one takes two parameters, a string and an integer. And inside the method, it does this, which is to say, take your integer, add 2 to it, print out the string, and then return my original integer plus 2. So anything that's a simple method that has a return and takes some arguments can be declared on the fly in line with your code as an anonymous method. And once you've done that, you can actually pass it around as parameters. So it makes it very easy to do things like, in the fork join effect framework, what you're trying to do is parallel processing. So you can actually say, here's the method that I want you to go off and parallel process with. So what it should do is simplify existing APIs. So where we said before, if I wanted to add an event listener, I would create a new listener object and override its method and tell it what I want it to do. What I can actually do is say, well, I'm going to create a listener. It's going to take a parameter of event, and what it's going to do inside its method is say, if my state is active and it's interesting, then do something and return that. So I can actually create that in line as a lambda method. Now, that allows you to do internal operations a lot easier, and you can do things in terms of internal recursion. So if you're iterating over a collection, you can do, today, 4 elements of in my collection called element.reset. Now I can do the same thing using a new function called, new method on each collection called for each. And I can say for each of the elements, I want to perform this method. And again, I could pass this method in as a parameter if I wanted to. So where you're doing that, one of the new methods which are being added to all of the classes is something called for each. And that brings us on to, no, it doesn't quite, okay. And there's also support in lambdas for stream operations. So where you're iterating over streams, it makes it much easier to do that. But if we come back to the for each method, okay, so one of the things that's happened in Java 8 is every collection is now going to have an additional for each method. Now, one of the problems with that is, whilst you've got binary compatibility, if you take code that works on Java 7, you try and run it on Java 8, it will run. If you try to recompile your code on Java 8, you'll start getting errors because you haven't implemented the for each method if you're subclassing a collection, or you're subclassing something that now has a for each method. So you have to do your own implementation of it because it's a new interface method. What they've added in Java 8 is for the ability for you to create default implementations. So when you create an interface, rather than just creating the method headers, you can now implement a default method. And this means that you can now add things into interfaces in later releases. without having to worry about breaking source compatibility when people try and move up levels of API. They don't have to now do an implementation of that method because it's required as part of the interface. They will just automatically pick up the default version. And the way it chooses which default to use is basically in terms of inheritance, it will take the lowest level of inheritance that provides a version of the method. So if I'm extending an interface, and that interface is an implementation of a default for that method, it will pick that up for you. If its superclass also has a default, you will take the lower one because it's closer to your function. And I think really one of the last things that they've added to Java 8 in terms of language changes is annotations on Java types. So in Java 6 they added annotations so you could annotate methods. What you can now do is annotate Java types as well. So you can take a string and you can annotate it to say this should be non-null. So it's just extending the scope of annotations and really will get used by IDEs and those kind of people to improve tooling to do development time checking for you. They've added a new support API. So there's the date and time API. Date and time has been catastrophically bad in Java for years. As countries around the world change their time zones, and there seems to be a tendency for countries to change their time zones on different days in different years. When it came to the millennium, there was a small island off New Zealand that elected to change it so that they would change their time zone so that they would be the first place in the world to be in the new millennium. So they just elected to do that, and any country can elect to change their time zone at any point in time. So every time that happens, the JDK has to be updated to know about the new map of time zones. So we've had problems maintaining and keeping the time zone format consistent. So there's some rework needed on a maintenance side. But there's also the problem that actually a lot of the date and time API was spread all over the place. So there were bits of it in Java util, there were bits of it in Java SQL, there were bits of it in Java text. And it's just been very bad. So it's one of these things that needed refactoring for some time, and it's just been refactored. So the final thing that they did, and this isn't something that they really did, that's what they intended to. Basically, there's been this whole drive to reduce the footprint of Java for some time. And the aim in Java 7 was to do modularity. That got pushed out to Java 8. It's turned out that they're finding modularity much harder to do than expected. When you think of modularity in Eclipse, and you think of it in OSGI, one of the advantages, almost everything there is done as a Java bundle. When you start to want to do modularity in the JDK, then you have to start worrying about native code. And in fact, one of the goals of Oracle is to make the JDK itself modular. So whilst they're having problems doing this, they also know that there is a need to take the JDK, which is now 105 meg as a zip file, 210 meg on disk, and make it smaller, because we're now looking at much smaller devices, ARM, Linux on ARM, Raspberry Pi, etc., trying to run Java. So they want to make it smaller. So their stepping stone on this path in Java 8 is something called profiles. So they're calling them compact Java SE profiles. So what they've done is they've created a profile called compact 1. This is 10 meg in size and contains only a very basic set of the Java class libraries. So you get things like Java Lang, I/O, text, math, networking, and some security. So it should be the minimum amount to be able to run something on a server. No UI, no GUI. If you need more than that, they created Compact 2. And Compact 2 is 17 meg and consumes Compact 1, so it's an extension. There you get XML, you get SQL, you get RMI, you get some of the transaction code. After Compact 2, they've gone for Compact 3, which starts to give you Java lang management, gives you the ability to do bytecode instrumentation, more cryptography, scripting, remote security and authorization, and so on. And then you've got the full Java SE. So what they're trying to do is say, we've got these profiles that you can now use. It's not modularity, right? You can't pick and choose which packages you actually need in order to run your application. You can't have them dynamically load at runtime which ones you need. But what we can do is basically make sure that each of these profiles are distinct and isolated. So there is no cross-linking between them. There is nothing in Compact 2 that requires a class from Compact 3. So when they were doing modularity, they were breaking the packages down, breaking the links between different classes down. And this is as far as they've managed to make it for Java 8. So Java 8 should be out in September. It's got Lambda support in there, which is going to make it easier to write certain types of code, and probably will be of a big benefit to anybody that's doing large parallel computing. For a number of other people, I don't think it's going to be a big change. It's just bringing parity with other languages. It's got compact SE profiles. One of the benefits for that is the fact that you can now run on smaller devices. It's got some date time changes, but again, there's nothing particularly major in there. But some of the stuff that's coming down the line is looking better. So there's modularity and reduced footprints. I'm not actually going to talk too much about that because it's becoming clear that Oracle don't yet know how to implement it. Right? What they do want to do is allow you to take something that would be your application in a jar file. And in fact, the whole of the Java SE API will be a collection of jar file modules. You'll create a registry on your machine that has access to all of them, and when you deploy your application, you will just define which modules it needs, and it will load only those into the Java runtime. And in fact, it should be able to pull them off a public website as well. So if you've used languages like Node, it's exactly the same. When you create a Node application, you add a package.json file that says, these are the modules that my Node instance needs. And when you deploy it, it reaches out to a public cloud broker that brings down the latest versions of those modules. So that's where they want Java to get to, but it's still not clear how they're going to do that. So we'll leave that to one side. Another thing that's being worked on is the idea of structs 2.0 or packed objects. So when you create an object in Java code, you get a Java object on the Java heap, which has a defined layout, which is particular to Java. It's not possible to have another process running C or COBOL or Fortran access your data that's on the Java heap. So this means that if you want to take something that's on the Java heap and give it to another process, you have to serialize it and then pass it over using a common protocol. So this is what the orbs for, this is what we use XML transforms for, this is what SCA or any other transform format is for. You take your Java object, you put it in a common format, you make it into a binary file, you send it over a network or into a file, something picks it up the other side. What the whole idea is for data access platform integration is to say, well, why don't we just write it to a shared bit of memory in a format that's defined that the other side can read. So it should be allowed to do I/O in Java without having to do serialization and going into intermediate file formats and sending it over a wire. And then the other two things are cloud and multi-tenancy and other language on the JVM. And those are the two that I'm going to go into. I'm kind of biased on the first one because it's one of the things that I work on. And for the second one, I think it's just actually quite some interesting work that's going on. So cloud and multi-tenancy. This is kind of built off a Gartner report that says that for enterprise customers, where everyone used to be is on the far left. Right? When you were running your applications inside your data center, you have a data center floor. You have infrastructure, so let's think of those as machines. On each machine you have an OS, some middleware, your application, and then you have users on your application. So this is where we used to be on the far left. Then what happened was someone came up with the idea of sharing hardware. Right? So this is virtualization, having two operating systems, maybe two instances of the same operating system running on the same hardware. So if you use VMware or any hypervisor, what you've got is two virtual operating systems running on the same machine. So that was a step forward, and it meant that we could share servers. Now, the step after that of getting more and more densely packed applications today is sharing an operating system. So you may have a virtual operating system, but you could run 4 or 5 Java processes inside it. So that allows you to pack more software together. And you can go further than that. You can share your middleware. So if you use an application server, you can run multiple applications inside your application server. Okay, that's fine. And on the far right-hand side, you can actually share an application. So if you think about it, Facebook has thousands of users running the same application. So as you get further to the right, you get more users and more units of work off the same hardware and the same software. But as you move to the right, you also introduce problems. So if I have 2 Java processes running in the same operating system, one of them can use all of the memory. One of them can use all of the CPU, and it steals from the other one. Right? That's one of the problems that we tried to solve by having virtual operating systems. Rather than having 2 processes in the same OS, and one of them could use all of my physical memory and all of my CPU, I've kept them separate by having 2 virtual operating systems. So what we're trying to do in Java is actually do the same thing. So the shared middleware case supposedly solves that because you have middleware with 2 applications running on top of it. And the middleware needs to be responsible for keeping those applications apart. Now, the problem there is that you do get collisions. Right? If both applications want to use the same URL, or both applications want to set a static variable inside a class, then you have a problem that you can't run those 2 applications inside the same middleware. You have to run 2 lots of middleware, possibly on 2 different machines. So you get collisions in terms of URLs, cache, CPU, memory, and I/O. So what we've been working on is something called the multi-tenant JDK. So the idea is, inside your machine, right, you can do this on your laptop. If you were to run 2 Java applications, you currently get 2 running JVMs with 2 applications. But one can steal the CPU from the other. If one of them starts running at 100% CPU, and you only have one CPU box, your other application gets no CPU time and effectively hangs and gets no work done. So what we're looking at is, if you want to run 2 applications, you can run them on the multi-tenant JDK inside the same Java process. And that Java process will keep the 2 separated. So if you look at what happens today in terms of virtualization, if you've ever used VMware to run virtual operating systems, when you run VMware, it gives you file system isolation. So you appear to have 2 file systems. Each of those is a disk quota. It can limit the amount of I/O each process can do. It limits memory, it limits CPU, it limits network. Now there's a layer on top of VMware and OS isolation called something like OpenVZ. So this is a lightweight OS container that looks like an OS, but is actually the kernel faking up 2 copies of your OS. And that has all of the same support. So we're building the same things into the multi-tenant JDK. We can say that your Java application has a limit on the amount of I/O it's allowed to do. It has a limit on the amount of RAM it's allowed to use. It's got a limit on the amount of CPU it can use. So what that looks like is this. So if you want to run a multi-tenant Java application, the first thing that you do is you say, I want to run multi-tenant Java rather than normal Java by just adding -xmt. So it's probably hard to see, but you do Java -xmt -jar 1.jar. Right? My application is called 1. So that's all I do. I add -xmt on the command line. What this will do is, it will create a Java process called JavaD, the Java daemon. If you don't have one already, it will create it. If you do have one, it just locates it. It finds it using a semaphore to find out where the process is. It then takes your application and creates it as a tenant inside the JavaD daemon. So at this point, it looks pretty much the same as just running Java, right? I have a JVM and I have my application, right? Nothing's changed. Now, if I wanted to add a second tenant, I do exactly the same thing. I run Java minus xmt to say multi-tenant Java minus jar, and I'm going to run my application called 2.jar. So it's a completely different application. But we follow the same process. I locate the JavaD daemon, and I create the second tenant inside the same JVM. So I've got one JVM running 2 Java applications. And I can actually put controls on each of these. So if you do minus xmx512m to say, I would normally create a JVM with a 512 meg heap, it means that this tenant cannot use more than 512 megs worth of heap. If it does, it gets an out of memory error, exactly as you would before. But on top of that, you could say, well, actually, I don't want it to ever use more than 2 CPUs worth of CPU at any point in time. If it does, if it tries to, we just stop it. We slow the threads down so it doesn't use the CPU. So this can no longer steal CPU time from this, and it can't steal memory from this. So I can have multiple Java applications running inside the same JVM, relying on the JVM to isolate them from each other, whilst at the same time getting an advantage of having one copy of common code. So whilst these may be 2 completely different applications, things like Java lang object, right, file input and file output stream, you only need one copy of these. They only need to be just-in-time compiled once and stored by the Java daemon. So you've got lots of memory structures which are shared. And you've got lots of optimization done by the just-in-time compiler, which can now be shared between the 2. So you get a massively reduced memory footprint, and it starts up faster. So you've got a much faster startup time and much lower footprint, which means that if you wanted to run this on a server environment, and you're running an environment for your developers, you can have thousands of developers running inside the same JVM at much reduced memory footprint, so you save on your hardware. Now, the other one is other languages on the JDK. So what I said earlier was a lot of the language changes which have been brought into the JDK have happened somewhat because of competition from other language vendors. So we brought in Lambda support because other languages have Lambdas. We did a lot of the small changes in Java 7 and more in Java 8 because it was things other languages already did. Right? Most other languages let you switch from a string. So we've now done it to kind of compete with the other languages for developers. One of the other things is, in the good old days, all Java applications, well, all enterprise applications were Java, and all you had to do was Java. There's now an increasing trend to start writing applications in other languages, or in fact to have applications which are multi-language. Right? There's quite a big trend these days to do the presentation layer using things like JavaScript, particularly with the move to HTML5. So one of the problems with mobile platforms is there's so many of them, right? You write your mobile application for iOS or Android or one of the others. And if you were to do it in native iOS or Android code, it's different. You've basically got to write your application twice. Now, HTML5 is supposed to solve this. And that means you've got JavaScript that you can write on the client side, and you've got JavaScript that you can write on the server side. So you end up with the presentation layer being in JavaScript. But there's not really good implementations of server-side JavaScript for enterprise applications at the moment. So you end up with people doing applications with multiple layers and different parts to it in different languages. So lots of different languages being used, and those have got lots of different frameworks. So if it's Java, you're using Java EE. If it's Ruby, you're probably using Rails. If you're using JavaScript, you're probably using Node, and so on. So lots of different languages out there all being used together. So what the JDK has done is try to build in support for you running other languages on top of the JVM. So in Java 7, they brought in JSR 292, which is called Invoke Dynamic. There's also been added an API for interoperability. So certainly JavaScript and things like Python are doing big support for JSON. So JSON support is now being built into the latest version of the specification. And this means that you can now start running other languages on top of the JVM, and you can do interoperability with other languages. So support for things like Python and JRuby have been around for a while. And the JVM is trying to make sure that if you write another language, you can run it on the JVM if you want to, so that you can embed other languages into your Java code. Or if you just wanted to run another language on an enterprise runtime. So by being able to run something like Python on a JVM, you get monitoring and diagnostics inbuilt for free. You get a just-in-time compiler for free. Right? These are all things which things like PHP and Python don't really have in their own runtimes yet. So it kind of brings them up to speed very quickly. But there is a problem for this, and that's that most of the new languages are dynamically typed, and Java is statically typed. So we're trying to make dynamically typed languages run on a strongly statically typed JVM. Now, whilst Java is statically typed, most of that's actually at the compiler level. Once you've compiled it and you've converted it down to bytecodes, at the bytecode and opcode level, it can actually deal with dynamically typed languages a lot better. So they do have, the opcodes are typed for the primitives. So there's a type for int and a type for long and a type for double. But when it comes to objects, those are just an object reference. So we have opcodes that just deal with objects generically. So whatever their type is, we don't really care. So when you're moving variables around, that works fine. Where Java is strongly typed and enforces it is when you do method invocation. When you call a method, it uses the full method signature, and that includes the return type and the type of all of the operands that goes into it. So the problem with Java running dynamic languages isn't dealing with variables, it's dealing with calling methods. So what they did in 292 in Java 7 is to introduce what's called invoke dynamic. So that's a method caller which can then be dynamically typed later. Again, it's not something that any Java programmer is ever going to need to deal with unless you're trying to write a framework for running JavaScript or Ruby or Python on top of the JVM. But for those guys, what it means is that they can runtime wire your caller to the type that you're calling. The simplest analogy for this is if you've seen films of how telecoms exchanges worked in like the 40s and 50s, where you had a lady that gets called and is asked to put you through to a given number, and she puts the wire into the box for you, then that's effectively what Invoke Dynamic does. You make a call and you build a framework around Invoke Dynamic that says, okay, what do I now need to plug this into? So it puts a level of indirection in there that allows you to now call a method to any type. Now, the effect of that is it makes dynamic languages run significantly faster. And in order to prove this, Oracle started something called Project Nashorn, which is JavaScript running on the JVM. Now, there used to be, or there still is, a Java on the JVM project called Rhino. So Nashorn is German for Rhino. So it's the next evolution of this. And Rhino was in the days before Invoke Dynamic. So what they've done is they've done a new JavaScript framework that uses Invoke Dynamic. On the left-hand side is a chart that I've stolen from the Nashorn team's presentation at Java 1, where they show the compatibility. So the top line is Nashorn, where they basically say they're 100% compatible with the JavaScript API. Rhino is at the bottom, which is at about 90%. So they're basically saying we've got better functional compatibility than Rhino did. On the right-hand side is the difference in performance. So the red bars are Rhino, the white bars are Nashorn. So the effect of using Invoke Dynamic is that JavaScript on the JVM now runs up to 4 times faster. And when they produced these slides, they did say that so far they've been concentrating on functional compliance and not performance. So that's the performance that they got pretty much out of the box, and now they're doing performance engineering with the aim to GA this with Java 8 in October. So at that point, they should have significantly better performance for running JavaScript on the JVM. And again, if the question is, why would you want to do that? It's back to, if you want to serve applications on a mobile, then you want to be serving HTML5, and you want to be able to use Dojo and Ajax, etc. on the client side, and being able to write JavaScript on the server side and the client side allows you to do that much more easily. So that's our whistle-stop tour of what's happened with Java over the last 25 years, what's coming in Java 8 and some of the stuff that's probably coming after that. So questions?
Can I go back to basics?
I think we're all a little bit, maybe a little bit stunned. I mean, my immediate reaction is that's a lot different from the Java last time I touched it. But you had a question.
I'm not a Java programmer at all, but the recurring theme that I get using Java applications is when it goes wrong, you get a little list as long as you're armed of function calls. Is that just bad programming, or is that inherent in the language?
So the question was, when you get a problem with Java, you get a huge stack trace. And does that mean that Java's done a bad job and they're inefficient, or does it mean something else? I think it's a good and it's a bad thing. Right? It's a bad thing because it means that it's 15 years worth of evolution that has led to layers on top of layers on top of layers. And it's true that the download size, as we saw on the Compact SE profiles, is like 120 meg for full SE now. And that's because they've allowed frameworks to build on top of each other. The other side of it is it provides a lot of transparency. So you can see what is happening. And one of the things that you can actually do with Java now that I've not seen really that well with other languages is that whilst you have a stack trace there, you can actually now get a stack trace where you see every operand as being passed at every level of the methods in the stack trace. And you can see every object that's being referenced from those stack frames. And you get the ability to do that because it's Java. So in some ways it's a good thing because you get that detail, it makes it easier to debug. It's a bad thing because, yeah, if you've got stacks which are 150 frames deep, you're doing something wrong. And it's where it's evolved over time, unfortunately.
Can you actually switch that off for when you're actually releasing the application? Or is that just inherent in the language?
So can you switch it off? Yes, you can actually say, give me exceptions with no stack trace. And generating stack traces is pretty expensive. So yes, there is an option to turn it off. And I think, in fact, they recently modified the options that you can limit the number of stack frames that you get. But yeah, it's also true that your application should really run clean with no exceptions. so then you only get the 150 frames when you need them.
Can you collapse it so you don't get, say, the bottom levels that you're already happy with?
Well, yeah, so I think they brought in an option so you can say only give me the last 50 frames or so. Yeah.
Okay.
Well, I can't resist one comment. I would just like to say that all languages would have this stuff. It's just ending up under the carpet and nobody looks. But what I really wanted to ask is, well, I mean, I've got several questions, but well, I think the most important one is about generics, because well, that has only been half done in Java when it was introduced, and the second half has never been done. a result of which is that, well, to my knowledge, to this day, it's not possible to have arrays of generic types, and where many other funny properties that, well, much as I can tell, all trace back to the concept of erasures, which I think is not particularly fortunate, to put it mildly. I mean, are there any, is there anything on the horizon that this could be fixed?
I'm not aware of anything, no. It's fair to say that I think generics was raised as a JSR maybe 5 or 6 years before it appeared. So it took them a while to get to where they did. But no, I'm not aware of anything that's designed to add generics to arrays. There is work being done on arrays to make them more efficient, to try and pack their size down. And
I mean, that's quite different though, because, well, I mean, it does get very difficult to express things that, from the perspective of the problem domain, are entirely reasonable to express, but then it's not possible because of the limitations of, well, what I consider to be a somewhat half-baked generic system.
well, so the thing is that a side effect of being able to do arrays of structures, which is what they want to do, is that it might actually introduce the generics to the arrays as a side effect, because you're now saying it's an array of this type.
Did you have another question?
Well, maybe I should.
Well, let's somebody else have another question.
Yeah.
Over the back.
You've been involved with Java for a number of years. You mostly worked with Sun, and then you've worked with Oracle. Which one's easier to work with?
Well,
what changes did you see?
It's largely the same people. And I think the interesting thing is that, so for about 8 months before the acquisition, and 8 months afterwards, it was very difficult to get anything out of the team from Sun. So it was like they didn't know what they were allowed to talk about anymore. And you still see it now that they're under Oracle. In the same way I showed the disclaimer on the second slide, they now have to do a lot of things that IBM makes you do, like go through revenue recognition training and what you are not allowed to talk about before it's been released. So you now see a lot of people very nervous about talking about things that they would be quite happy to talk about in the past.
I used to work for Sun, so I know it was a fun place to be. I'm not sure whether Oracle was quite as much.
Well, isn't it true that the industry has a history of companies that start young and are very freewheeling, and they end up a little bit different? That might happen to Google one of these days. Right.
Yeah, there's been some security issues around the Java language, which have forced people to update their own machines, the language on their own machines, or even switch off. I've switched off Java in my browser.
Yeah.
To no noticeable effect, which sort of surprises me a bit. But would it be, therefore, is it true to say that most Java development is now on the enterprise side rather than on the fishing around on the client side?
So it's fair to say that all of those security vulnerabilities, or 98% of them, only affect the browser. So that's where it's vulnerable. At server side, we had probably a fairly large vulnerability 2 years ago, which we patched pretty quickly, which was a denial of service on, if you gave a particular number into parse double, it went into an infinite loop. But all of the other ones have been on the desktop, and like from an IBM perspective, we're not interested in Java on the desktop as an enterprise language for us.
Right.
It's kind of more interesting for Oracle, because Oracle make money out of Java on the desktop. They sell it to enterprise customers as something on the desktop, and they sell support for it. And it does seem that they've done a fantastically bad job of securing it. Now they keep coming out with new UI languages. So Java FX is recent, last 2-3 years or so. So they are investing as Java on the desktop. But I think they're less interested in Java in the browser anymore. they're trying to say Java should be like a desktop tool UI, so you run standalone Java on the desktop. I don't think there is that much interest in Java in the browser anymore. Right. If you think about things that you can do in applets, HTML5 is supposed to let you do most of this stuff. Ajax and Dojo lets you do this stuff. So personally, I don't think Java in the browser's got too much of a future, but I don't work for Oracle and I don't own that area.
I was astonished that switching it off made no difference to my world. Yeah, totally.
Okay.
C++ has just been through quite a sort of major change, the latest standards, and seems to have overtaken Java in some areas like type inference. How do you see the comparison now between the new C++ and Java?
So I've never been one for you get people who strongly advocate a language. And my opinion's always been use whichever one makes it easiest for you to do the job. Now, as I've been saying, kind of the problem with Java is it's been kind of stale and it's taken a long time to catch up with other languages. And it's good that they're now paying attention to that. So as the other languages are coming forward, that Brian Gertz and the team, he's the language architect, is responding to it and trying to put new stuff in, but I don't use C++ enough to know the difference, unfortunately. The work that I've been doing recently is actually much more in Python, Node, and PHP.
More questions? Yeah? Okay.
How did the name JavaScript come about?
I've no idea, but it's incredibly annoying. The number of people who hear JavaScript and assume it's Java, in the same way that in my first 3 or 4 years at IBM, I worked on JVMs, which meant I wrote all of my code in C and assembler. And loads of people would ask me, how do I do this in Java? And I'm like, I don't know, I don't write Java code, I work on Java virtual machines.
It used to be called LiveScript. It was developed independently from Java by Netscape to put interactivity and animation into their web browser, Netscape Navigator.
Yeah.
And they didn't know anything about Java at the time. Sun didn't know anything about LiveScript.
It looks almost the same.
And then they, well, it does, in many ways, it looks the same in that it has curly brackets, but that's pretty much but they actually had a meeting together and discovered the Java applets in JavaScript were doing almost the same job. Sun agreed to let Netscape rename it because it was felt to be a little bit similar and it ran in the browser and gave them animation. But they're the similarity finishes.
That might have been a mistake. Was the
Well, I mean,
piece of original confusion.
Nobody needed Java applets anymore after JavaScript. Some of them were the ones that lost out.
Yeah, go ahead, John.
A bit of trouble. I always thought that the German for rhino was killed.
Well, as I said, Nashorn is German for rhino. Now maybe they've got more than one word. I don't know.
Rhino is a slang word for rhino.
Yeah, it counts as money in German. Yeah. There are a lot of, I think, very familiar themes that people tried to solve in languages 25, 30 years ago here, which look as if they are still being worked on, and we may get solutions one day. But I think there's just one question I'd like to ask, if I may, Chris, which is we've had a number of presentations on functional languages, and we know that some of the major players in the industry have introduced pure functional languages, or nearly pure, somewhat pure functional languages for particular markets. How far do you think this takes, the Lambda stuff takes Java into functional territory?
Well, the advantage is that we don't need to because there's Scala. And Scala is functional programming on top of Java and the JVM.
All right.
So it's one of those things where Again, I don't think Java needs to do everything. It just needs to work with the language that you're running with if you've got particular problems that you're solving. So it just needs to be an open system. And Scala is probably the biggest language on top of the JVM at the moment, other than Java.
And there used to be people who objected that the JVM would never support certain types of languages. Do you think the changes are happening that will let that take place?
I think as long as Oracle wants to keep Java front and center, they'll continue to do support for other languages of any type. Doing statically typed languages is easier than doing dynamically, and now that they're supporting those, it's clear that there's a stake being put in the ground that they will carry it forward.
Yeah. Well, any more questions? I think we owe Chris a very big vote of thanks for. Before you all dash out, is there anybody who hasn't signed the attendance register? Over there. There you go, behind you. Just please do sign it before you leave. If you would like to join us at Champagne Charlie's wine bar afterwards, you go along the Strand to Charing Cross Station, turn left into Village Street, halfway down Village Street, turn right under the arches, and that's where we'll be.